Before we add the noise, we actually want to remesh this rock because in its current state, we still have, let me just take an exploded view and increase the scale. We still have all the internal faces from each copy. That's not good. So we need to remesh it, but if you remesh it directly from its current state, I will show you how long does it take. I will stop and restart the recording when it's done. So as you can see, it's taking over a minute to remesh this thing. And not only that, this is with default setting. We will put a target size at the end of 0.05, so you can imagine how the time is going to increase. It will become something like 10 minutes. That alone will be unacceptable inside a setup for a single node calculation. And not only that, we didn't fix our internal issue. If we go inside, you can see that we still have some major problem of internal faces here. So the way we fix that is we use a boolean, we set it to union, and we plug just the mesh. No second input whatsoever, and that will immediately fix the inner problem we had before. The boolean node will clear all the internal faces and leave only the surface. So now we can actually plug it into the remesh. It will take much less to calculate, and we can set our final size to 0.05. Give it a couple of seconds, and there we have our rock remeshed with no internal issue. So now we can actually apply some noise to the overall shape. So let's add our first noise and drop down a point bop after the remesh. We will call it initial noise and dive inside. In here we will use a couple of turbulent noises, so let's create two of them. Plug the position inside the noise, and let's promote frequency, offset, amplitude and roughness of both of it. Then we are going to add these two noises together and plug the result inside the position. Now we need to make some changes because we want original purling and we want 3D noises for both of them. And of course we have to add it to the current position, so plug the original position as the third input of the add node. Now let's go outside and we just need to tweak the value of it. Also, let's edit the parameter interface and just add a separator so it's easier to take the two noises apart. So for the first one, we want to lower the frequency to 0.1, lower also the amplitude, let's round this value 0.32, and also lower the roughness. For the second noise, lower the frequency to something like 0.4. Also, we want to change the offset, so we won't have the same values as the other noise. And also here decrease the amplitude, set it to 0.35, and also the roughness. So now we have our initial noises, and I believe it's fine for the time being. Now we want to add another noise that will be only on the top side. So let's plug another point bop. We will call this one top noise. And let's dive inside. Before adding the noise, I just prepared a quick setup to explain what we're going to do. It's just a grid with the point normal pointing up on the y-axis, a normal node for visualization, and this will be our noises. Inside, I'm using a displace along normal with the position and the incoming normal, so by increasing it, we are moving on the y-axis because the normals are pointing that way. What we're going to use is called Worley noise, which is a cellular noise, so basically it works by scattering points in space. So we plug the position in the position of the Worley noise, and you have this different distance output. Now the way Worley noise works is it scatters points in space, 2 or 4 points based on the setting here, and it uses some algorithm to calculate the distance, and you can specify the algorithm here. But the practice is that, let's say you have one input point, the noise will scatter 2 points as it's set now 2 points, and it will give you different values as an output. Let's say this is 1 and this is 2. You have the output of this distance here, and you can do different operation with it. Let's say we just want to use the 1 point distance. You have this something like Gaussian effect, but not only that, you can do operation with those distance before feeding it into a displace along normal or adding to some other values. So what we're going to use is subtraction from the second point distance to the first, and we will use this as an amount for our displace along normal. This will give us this rock-like effect. So back to our rock, let's drop down a normal node after it, so we won't have any visual issues, and dive inside the point bob. In here, we will use a displace along normal. We will connect the position and the incoming normal and feed the output position. For the amount, we said we want to use a Worley noise, so let's plug the position in the position, and we will use a subtraction from the second distance to the first distance and use the output for the amount. Now we want to promote the frequency for sure, and also we want to be able to remap the incoming values. So let's maybe lower the frequency to 0.6, and we will promote the destination minimum and maximum. Now let's go outside, and we want a very low value here, something like 0.07, and we actually want to go negative with the minimum, so let's say minus 0.08, and don't worry about the size, we are going to filter those values soon. Also, we want to lower the frequency, something like 0.5. Alright, now we need to fix this side issue, also because we said we want the noise only on the top part. To do that, we can actually use the Y position, so we can filter this noise until a certain height is reached. To do that, let's go back into the point bob, and let's say we take a ramp. Let's unplug the position for now and take a vector to float, so we can input our position and have only the Y position used for the ramp, and output the ramp inside the color. So now if you go outside, we can see that by moving the ramp, we are filtering the Y position. Now we are using for the color, but we are going to use it for a multiply node before the displace along normal. Now the problem is that even if we reach like the end of our ramp, we actually aren't even at the middle of our mesh. That's because the ramp does expect values from 0 to 1, as now our rock is like 4 point something unit tall, and as you can see, the ramp reached only the 1 value at the maximum. So we need to remap this incoming value in a way that our mesh will go from 0 to 1. In order to do that, we can use the bounding box node. We connect it to the first op input, which is basically the first incoming node. And we use a get vector component to take the y component. And we do it 2 times for the minimum and the maximum. So basically we are taking the bounding box values from this mesh and using only the y value. So we have a minimum value for the y and a maximum value that will be that 4.1, I guess, 4.2. So now we can fit the actual y position, connect the minimum to the search minimum and the maximum to the search max, and feed this into the ramp. So now go outside and you can see that we have access to the whole height of our rock. So now put the display flag on the normal node and let's set this value like something here. Also, if you press D, in the guides panel, you can disable this current geometry flag. This will allow you to hide the information of the currently selected node if you want to display on another node. So it may be convenient for you. Let's go back into the point bob and unplug the color, plug back in the position from the display surround normal, and let's create a multiply node. So now we can multiply the result from the fit range of the noise with our ramp and feed the product in the display along normal amount. Now, if we go back outside, you can see that by moving the ramp, we are filtering this noise on the rock height. And that was exactly what we wanted. Now, as a final thing, I want to actually pre-distort the overlay noise before it will actually drive our displays along normal. To do that, we will use a turbulent noise. Let's feed the position in the noise and let's make some room. And we want to add the current position to this noise. That will be an original Perlin and a 3D noise. And the result of this addition will be the incoming position for our overlay noise. So we basically pre-distort all this effect before it's actually fed into the noise position. And we want to promote the frequency, the amplitude, and the roughness. That should be it. Let's go outside. And let's see. We have the minimum and maximum, the ramp. Let's edit parameter interface so we can order some things. So we want the minimum and maximum value at the top. This is the frequency for the overlay noise. This is the ramp. So we move the ramp at the last, and let's add some separator after the fit and after the overlay, and another one before the ramp. Apply and accept. So this is the frequency of the overlay noise, and this is the frequency of the turbulent one, so the pre-distortion. We want to lower this as well to something like 0.2. And I believe amplitude and roughness are fine. Yeah, it should be good for now. So we basically have our basic shape ready. The only problem left is that by adding those noises, we distorted also the part of the mesh that is touching the ground. We need to fix that. To do that, we want to create a group node, and we want this to be after the remesh. So let's drop down the group node, and we want to set it as point. We will call the group ground and disable the base group, and we will use a bounding box. So let's increase the size so it will take all the width and length of our rock. And for the height, we want something pretty small. We just want to take the base and maybe some other rows of points, something like this. Then after the toNoise, let's take an edit node. Let's call it move ground. Plug it after the second noise, and we want to edit the ground group. And let's say we want to shift it on the y-axis with a 0 scale on the y value. So basically we flattened the So basically we squish the whole base. So basically we squish the whole point group, and now on the soft setting you can say, perché non lo fa? So we basically squished the whole group. Now, if we change the group to point, we can actually set some soft radius. So let's set it to something like 0.4, so it will be a little bit smoother. Now we just need to add a transform node, and we want to compensate this translation we just did with the edit node, so we will move the mesh back to 0. So let's go back on the edit node, right click, copy parameter on the translation of the y-axis, and on the transform node, right click on the y channel and choose paste relative reference. But we want it in the reverse, so let's add a minus before. And we are back on 0. So let's drop down a null, make it green because it will be one of our main output, and let's call it out base rock. So now we have